Okay, is it on? Are we on? Are we going? Okay. This is from Algebra 2 like 10 years ago. I wanted to have a flashback. Um, and again, with our big change in our math, and some people from CAT and some people from Math 3. Actually, today the Math 3 people will know more than the CAT people in Algebra 2. Um, some people had an Algebra 2 honors 2 years ago. In that Algebra 2 class, we didn't do this stuff. You know mean, median, and mode, though. All right, so I'm not going over that again. Um, and then here's a list that you don't write down. Don't write it down. No, this is not on your worksheet. That's a worksheet actually in front of you that will be expected to be done tomorrow. So here's some grades. I'll write them for you next. I am not doing this though. Going to the graphing calculator and actually going through this process. But I will show you a couple things on the 84 that you have just because I did the other hours and I thought it was okay. And I'm not going to go through it with actually doing the numbers, but I'll show you what you have as options. Clear? You get stat, edit. Remember that? 84s. We went to the list and put a lot of stuff in our lists. And I'm not going to do this now, but what you could do is take this L1 list and just list these numbers 81, 70, 75, 100, blah, 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 blah. Once you're done doing that, you can get out of there and quit. And then just to make sure I can find where this is, what's helpful, which is what we're going to do next, is actually take that, no, wrong. There we go. Just hit the stat button again, and then you could sort on this main screen, enter, and then you could sort second L1, and sort A means sort ascending. So actually you could take this list that you just typed in order 81, 70, 75, and it'll put it from smallest to largest, which is a helpful tool. And then press enter. My list is, well, all it says is done. This list is not the one that I'm dealing with, but now when I look at this list, it reordered it in order from smallest to largest. I don't know. Then the next thing is second list math. Here's what I did with them back in the day. Mean, I could do the mean of L1, and I could do the median of L1. That's by doing it by one. There's also another button that does some of these things and more. Mode, I couldn't find it this morning. I don't know if there is a mode. Basically, once you see it in order, you could figure out the mode, which is the most occurring. So I just thought I'd share that. For an Inspire, I've never done it once. So you go to the list and then probably hit some sort of stats feature. But we don't need it, and it's not something it's expected of you to do. But there are many stat applications on the graphing calculator. So back in the day, I had the students order them. I actually remember doing that. Hit the list button, it orders them, and then we can write them on our paper. So if you want to start taking notes, this is the list we're going to deal with for making a box in Whisker. And I'm enabling the students that didn't actually watch the 15-minute video from yesterday. 15 minutes to miss 51. That's a nice little thing there. All right. So it's the same list that we had in the boxes, put in order from smallest to largest. So again, if you want to retake this, that's fine. If you were here yesterday, this is all the same as what we did yesterday. But I'm adding something, a mathematical concept about what an outlier is. Okay, so I'll leave that list up there. And I'll hold off for a second. What's the range? Very simple. 100 minus 32, which is 68. Great. Okay, then what we learned yesterday was on the video is quartiles, and what I've done is nicely color-coded this for your enjoyment. Okay, but today is a little different than yesterday, where the list is actually an even amount of numbers. There is an even amount. There's 24 total numbers in the list. Yesterday there were 17, so the 9th number in the list was the median in the middle. Now what we had to do to find Q1 and Q3 was ignore that middle number, because 8 numbers were before it, 8 numbers were after that, and then we found Q1 and Q3 from those 8 numbers. Where here, this is smack dab in the middle. So let's find that median first. The 12th and the 13th number are in the median position, so I have to find the average of them. So the median is 79.5. But then why I have this line here is To find Q1 when you have an even amount of data, you actually include, you don't cross out that 78. Okay? Whereas if there is just one number in the middle for median, you don't include that for finding Q1 and Q3. Now, we have 12 numbers here. Of these 12 numbers, the 6th and the 7th number are in the median position for the first 12 numbers. That is going to be called Q1, the median of the first half of the data. And then there's 12 numbers after. Okay, we want to find the median of that data. That's called Q3. And that has to be done by finding an average there. So in this scenario, you could see why we do this. This is actually perfectly cut into 25, 50, 75, 100% of the data by doing this process. All right. Okay. Now, this is going to be new for everybody. I love a mathematical representation of outliers. Outliers, we've been asked this before, but it's just been random, and you were supposed to just guess. It was on like your last test, you know, what of this data, who looks like outliers. Not last test, a while ago, very beginning of the very first chapter. Now there's, for a box and whisker, there is a mathematical representation of it. That's why I like it. So yesterday you were told to find the interquartile range, which is 85.5 minus 68.5, Q3 minus Q1 in that order. And just from memory, it's 17, right? You're always helpful. Okay, now focus and pay attention. This is new. Outliers mathematically. And actually, this is verified in your book. I wanted to find it in your book. It wasn't in your notes, but it was in like one of the homework questions. It describes what an outlier is mathematically, and it corresponds. I just wanted to make sure things didn't change. You know, you never know. But with our Algebra 2 book back in the day. An outlier is found by taking the interquartile range and multiplying it by 1.5, and then see if any numbers are outside of that particular number. So let's do that first. The interquartile range is 17. We're going to multiply that by 1.5. And if memory serves correct, oh, I'll be so embarrassed, but I think just last hour we got 25.5 there. Okay? Now, you'll see this at the end when we look at the box and whisker plot and actually incorporate outliers. Looking at Q1, what was our Q1 value again? I'll make it a big one. Now, what we want to concern ourselves is before 68.5, we want to subtract. Are there any numbers that are outside of this parameter? So left of 68.5, a distance of 25.5 grade points. This is a grading scenario. These are all grades in a class. And what do we get when we take 68.5 minus this 1.5 times the interquartile range? 43 on the dot? Okay. Are there any numbers that are smaller than 43? Outliers. What are they? 32 and what? This is what this means. I mean, look at the data here. They're test scores. And I think we could see that these test scores, look, this was a fair test. Fair, fair, fair. Okay, very solid. And then all of a sudden we got these two guys or girls. Okay, something's wrong here. They're outliers. There's a couple reasons maybe. They're not doing their work. They clown around. All the things that we talked about before this movie, you didn't get to hear that little diatribe. Or, sadly, it might be that it's just throughout their mathematical career, this is not the class for them. And that is not that you're a bad person, but it's just like this class, the math is beyond what you're capable of or whatever. That's what that says. If there were no outliers and we had some bad grades, then the teacher can make some different analysis there. So those are outliers, and that's what that means mathematically. And throughout the years, yeah, It happens. Now, there could be outliers in the opposite end. You could have, by the way, what's the cute quartile 3 number? 85.5. What do I got to do with this 25.5 in order to find an outlier on the other end? Add it. You want to see if someone's greater than that. Now, in this case, what do we get? 111? Is there any grades greater than 111? No. But how could this happen? This could happen if you had test scores like 50, 55, 60, 61, 63, 66, next highest one 72, then the next highest grade's 100. Well, that could happen, and that would be a student where, okay, maybe the test was not fair because the highest grade other than that 100 was a 72. That 100 probably should be in a different class. Because they probably should be in an honors class. So I don't know, just speaking out loud how an outlier on the other end would occur. And then I wouldn't really consider that number when saying is the test fair or not. Okay, blah, 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 blah. Well, we don't have any outliers on that end. Okay, so now here's the box and whisker, and now it's going to be complete with outliers involved. Ugh, that's a sad attempt at a number line. I'm going to put 20 here and 100 because it worked better than first hour, where I put 30 there because our first data value is 32. What's halfway between 20 and 100? 60, right? What's halfway between 60 and 20? And this is why I'm doing this, so I'm getting a scale. When you do a box and whisker plot, you do want some sort of scale that represents everything. I guess the word proportionally would work, but big yawn. Shh. Now, quartile 3. I'm sorry. Let's start with quartile. Wrong. What's the median? What was the median again? I already forgot. I got scared. Somebody punched something. What? 79.5? Okay. 79.5. Okay, this is why it's called a box and whisker plot. This is one side of one of our boxes. All right, and then I can see quartile 1 is 68. See, again, you don't want, these got to be relative to what, I think the one that I put online, the graph I put online, I didn't do the number line thing. And I would mark myself wrong. So just make sure you understand. Well, we're looking at the notes now. So, and then the 85.5, right? So 85.5 is somewhere around here. And then this is what you want. Okay. Then the highest grade is what? What's the highest grade? And it's not an outlier. Hundo. And then what's the lowest grade that is not an outlier? That's the point. 55. So I got to go to 55 and end the whisker right there. And then put the outliers. Okay, what was an outlier? 40? Right? And then what? 32. And you put them as dots. You can color them in or not, I don't know. But that just shows where those are. They are actually outliers, which if we made presumptions about the test being fair or not, you wouldn't count that as part of the data, I guess. So then dividing data into two parts, if finding the 64th percentile of the data, for instance, you are finding the number in the data that has greater than 64% of the data below it. It's an important concept, but also you have to understand what I'm going to do here anyway and why we're going to round up. How many numbers are in the data? Same data. How many numbers are there? 24. So why am I going to take 0.64 times 24? All I'm trying to find is the number in the list that represents the 64th percentile, where that is, 64% of the data is before it, let's say. Okay? Now, when we do this, I think we got 15.3. Anyone? 3, 6, blah, blah. What does that number mean? There's no 15.3 number in the list. There's either a 15th number in the list or a 16th. Where do you think I should go to make sure I'm at the at least 64% of the days before this number? Should I go to 15 or should I go to 16? It's actually 16. I want the 16th number. So this created a huge debate in fifth hour. Wait, I always round up, down. What do I do? And you round up because here's the 24th, 23rd, 22nd, 21st, 20th, 19th, 18th, 17th. All right. Unfortunately, 85, 85, 85. But this is the 16th number right here. If we went to the 15th number and rounded down, then less than 64% of the data would be before that. That's why we have to round up. I can't explain that any further. So yes, in this case, in this particular specific finding percentiles, you always round up because of what we just said there. 20th percentile, 0.2 of 24 numbers. And then I think this one we got 4.8. There's no 4.8th number in the list. There's either a fourth number in the list or the fifth. If we went to the fourth number in the list, less than 20% of the data would be before that. So that's not what I do. I go to the fifth number in the list. So this always rounds up. Sorry I didn't answer these questions then. 85 is in the 64th percentile, and 66 is in the 20th percentile of the data. All right, now it's time to go on to the next stuff. So let me blow up. Standard deviation is a measure of how each value in a set varies or deviates from the mean. The higher the standard deviation, the more spread out the values in the set are. So this is Mickey Mouse again. We did this back in Algebra 2. And kind of taking a step back between 9-3 day 1, which was yesterday, just box and whiskers. A little bit added, and then kind of what we're going to venture into tomorrow. Okay, so this isn't a minus sign. This just denotes some values that you should be aware of, and I just put a little chart back in the day. X is just the value in the set. That's not a minus sign. Just this is the symbolism for mean, which is average. And then what you do to find standard deviation is this little process. You take the X value that you have subtracted from the mean, then you're going to square it, and then there's a reason for that. After you square it, I guess I'll cover this now. It does go right here in the formula. Sorry for this extra pickup right there. What does this symbol mean? Sum, add. That's all it means. So you're going to take all that data after you take the X value minus the mean and then square each individual term. You're going to add all those up. Divide by how many numbers there are in the list, and then square root it. Seems like an arbitrary, crazy little formula that you're going to do here. I guess we give you a firmer understanding of this tomorrow, I hope. So what I did for the algebra tours back in the day is, okay, so you got these numbers. Here are the numbers in the list. Just maybe they're test scores. Who knows what they are? And they're very Mickey Mouse. You know, when we go into the worksheet that I put quiz on the top of it. Not really a quiz. The numbers are a lot more extravagant. There's decimals, and your mean is going to be a decimal, and so on and so on and so forth. I'll do the work for you too. The mean is add these all up and divide by 8. And you end up getting 80 for that. And that would be in all of this. Just to denote, what are you going to take all these values minus? So offline, we're going to subtract all these numbers and square them. But 50 minus 80 is what, everybody? Negative 30. And then negative 30 squared, though, is 900. Then we'll do all the rest of the math off. You know, a couple indications of last hour students trying to make correlations to stuff or improper extrapolations, not improper like illegal, but this just happens to be symmetric because this data, I was so like not imaginative on the numbers that I came up with. You notice how this is symmetric, 9400. There's no correlation to that whatsoever. Just an accident. But now what we want to do is sum these squares. I'll do that math for you. It's 2800. And divide it by how many numbers there are in that list. 8. And then the standard deviation, which is denoted by this symbol, is, I forgot. Let me look at my list. 18.7. I always put something wrong. And you could verify that yourself. Okay? And I'll give you a second to catch up. So what we're going to do as you're continuing to write this down is I'm just going to write this down on a number line, kind of graph, putting the mean right here, which is 80. Remember, standard deviation is about how far the values vary compared to the mean, the average. The standard deviation is 18.7. This is what I'm going to do next, kind of relates what a z-score is. If I go standard deviation to the right, 18.7, first of all, what's that data value? What's 80 plus 18.7? Very simple, 98.7. This is considered one deviation to the right of the data. Let's go the other way. What's 80? Wrong. Yeah, no, right. What's 80 minus 18.7? I thought I had them switched in my head. 61.3. I already did that number for me. Good. 61.3. This is one deviation to the left. One deviation left of the data. And that will, going left or right of the data, will be represented as z-score. Those that know what a z-score is, a number that's in here, what kind of z-score do they have? Positive or negative? I'm going to give you a hint. Negative. When we go here, what kind of deviation will this have? Or z-score, sorry, positive. So when you're greater than the mean, it's a positive z-score. Less, it's negative. Let's go one more deviation. Why am I going one more? Look at the data that we have. We go all the way up to what? 110. Is all the data covered in this, how many deviations? No. So add 18.7 again. What do we get? Thank you for the calculator work. I do appreciate that, and I mean that. 2 deviations to the right. Is going one more deviation to the left enough? Well, subtract 18 from 61.3. 18.7, I mean. What do you get for that? Is that enough to cover all the data? So all the data is covered in 4 deviations. Okay? No one ever does. Okay, all right. So you can look at this. I do have this example completed. It's just doing more of the same. So I just wanted to compare that to what a z-score is. And it actually pertains to how I charted that out using the deviations compared to the mean. So z-score is just the number of standard deviations that a value is from the mean. Simplistically, this may get more complicated as we move on in this book. This is a little formula, but actually the formula will make sense if I just graph this out. So let's just look at this first before we focus on the formula. The data set has a mean of 85. Let's stop. Let's draw 85 and then do what we did in the last question. Here's 85. Its standard deviation is 6. So that means if I go 1 deviation to the right, what's this number? If I go 2 deviations to the right, what's this number? Did we get to this yet? Which is the first question. What's the z-score of 100? We have not. So let's add one more, which is 103, right? And then what can we represent? What do you think the z-score, of 100 would be? Well, how many deviations did I have to move? 1, 2, 3 completely? No. So what can we expect for a z-score? A number between what? 2 and 3. That's exactly correct. Now I can go to this formula and then it'll make sense. Z-score is the value that you have minus the mean divided by the standard deviation. I'm going to go this way so I don't run into that one. Lo and behold, you get 15 divided by 6, which is 2 and 3/6, which is 2.5. So 100 would fall right around there. 1, 2.5 deviations to the right. That's why it's positive 2.5. Well, let's go backwards 6. What does this end up being? 79. And look at what they ask here. What is the z-score of 79? What is the answer right away? -1 is correct, because it's 1 deviation to the left below. Or 79 minus 85 divided by 6. Right? So in graphical form explained, I guess.